How to solve linear inequalities. The steps for solving linear inequalities are very similar to the steps for solving linear equations. So let's go through them just to review. The first step is to remove parentheses, and we do that by distributing. The second step, we're going to clear out any fractions by multiplying by the LCD. Third, we're going to combine like terms. Now, step 4 is the one that is a little different than linear equations. It says isolate the variable on the left. When we solved linear equations, we did not care which side the variable was on. It could be on the left or the right. But for inequalities, we definitely want it on the left. It just makes it easier to graph on a number line and write the interval notation. And one other thing that's important here, if you multiply or divide by a negative number, reverse the direction of the inequality symbol. And the reason you have to do that is so that the statement will remain true. Let's look at something like 3 is less than 5. So we know that this is a true statement right now. 3 is less than 5. If we multiplied both sides by 2, it would now say 6 is less than 10, which is still true. But let's say we had multiplied both sides by negative 2. Then it would say negative 6 is less than negative 10. And that is not true. For it to be true, we would have to reverse the direction of that inequality symbol. And now it's true. So it's only when you divide or multiply, most of the time it'll end up being dividing, but by a negative number. That's when you reverse. If you divide by a positive number, you do not need to change the direction. So let's practice. The instructions say, solve each linear inequality, graph the solution set on a number line, and give the interval notation. And that's what we practiced in the previous video. So step 1, remove parentheses. That means we need to distribute the negative 3. So negative 3 times 1. And negative 3 times negative x is a positive 3x. And make sure you just, for right now, you drop down that same inequality symbol. Sometimes I see students make the mistake of turning it into an equal sign. So just be careful that you keep the inequality symbol. There are no fractions, so we skip to combine like terms. And on the left side, we're going to combine 4 minus 3 to be 1. Next step, we want to isolate the variable on the left. So I want 3x to stay on the left. That means I should subtract 1 from both sides. And I'm still keeping that same inequality symbol. And then last, to get x all by itself, we're going to divide by 3. We're dividing by a positive 3, so we do not reverse the symbol. 0 divided by any number is 0. So we've isolated our x. The solution set are all values of x that are less than or equal to 0. So now we're going to graph that on a number line. Remember, you're going to draw your line with arrows. You're going to put a tick mark and put your number, which is 0, below. And then we're going to shade. It's pointing left. We're going to shade left. We're shading all the numbers that are less than 0. It does have an equal bar, so that means 0 is included. Show that with the square bracket right on the tick mark towards the shading. And then we're ready for the interval notation. Remember, left to right, and this one goes forever left, which we represent with negative infinity, comma, and our rightmost number is 0, which we are including, square bracket, and always parentheses on infinity. So all of this is part of our answer as well. When we graph inequalities, we want to always include, when we solve inequalities, we want to always include the graph and the interval notation. Let's try another one. This one again has parentheses, so we are going to start by distributing negative 4x, negative 8, bring everything else down. And here's where we really need to think about, okay, we want the variable to be on the left. To make that happen, I would subtract the 3x from both sides. That means the constant needs to be on the right, so at the same time, if you want to, you could go ahead and add the 8. If you prefer, you can do that in a separate step. So now on the left side, I have negative 7x. I'm still just dropping down my symbol, keep it the same. And on the right side, we have 28. Now, to get x by itself, we need to divide by negative 7. Because we want to end up with a positive x. So if that number in front of x is negative, then you divide by negative, and that causes us to reverse the direction of the inequality symbol. Let's make a note of that here. You might want to put that in your notes. We're going to reverse since we divided by a negative. Very important to remember that. And then we answer 28 divided by negative 7 is a negative 4. So the solution set, all values less than or equal to negative 4. Another mistake I sometimes see students make is they try to reverse the symbol too soon. So make sure you do not reverse until you write the result of that division. Okay, our number line, we've got a negative 4. Less than, we're going to shade left. And equal to, we're going to include the negative 4. Square bracket. And then our interval notation is going to, like the last problem, start with negative infinity and go to negative 4, including the negative 4. Okay, so on both of those first two examples, we had to distribute. We didn't have any fractions. But on example 3, we want to go ahead and do an example with fractions just to review that. We covered it with linear equations. So remember, to clear the fractions, you multiply by the LCD. In this problem, our denominators are 3 and 9. And 1, which because that 1 that's not a fraction really has a 1 as its denominator. But you can just focus on the 3 and the 9. So the LCD is 9. So let's go ahead and write 9 next to each term. Remember, even the term that's not a fraction has to multiply by the LCD. To clear the fractions then, we're going to divide the denominator into the 9. So we say 3 goes into 9 3 times. And we multiply the numerator times the 3, so 2x times 3. On the term that's not a fraction, just multiply. So 1 times 9 is 9. And on our last term, we're going to divide. 9 into 9 goes once, and 5 times 1 is 5. We want to keep x on the left, so the next step is subtract 9. Keep your symbol. And now to isolate, we're going to divide by 6. So the number we're dividing by is positive, therefore the symbol does not reverse, it stays the same. Even though our answer is negative, that doesn't affect the symbol. It's only if you divide by a negative or multiply. So symbol stays the same. Here we have a fraction, so just simplify your fraction. You're going to divide top and bottom by 2. It's going to give us 2/3. So the solution is x is greater than negative 2/3. Let's graph that on a number line. When it's a fraction, that's okay. You just write that fraction below your tick mark, negative 2/3. Greater than means we're going to shade to the right. There is no equal to bar, so we're not including the negative 2/3. We're going to show that with parentheses towards the shading. And our interval notation start on the left, so our leftmost value is negative 2/3, comma, goes to the right forever, and we would need parentheses on both. So here we just want to notice we're going to clear fractions like we did with the equations, and when we divide by a positive number, we do not change the symbol, even if the result is a negative number. Now, sometimes when you're solving, just like with the equations, the variable may be eliminated, disappear from the inequality. If that happens, you're going to look at the statement that has just the numbers in it, and if it is false, your answer is no solution. If the statement is true, all real numbers, and remember you can abbreviate that with that big R. The interval notation for all real numbers is negative infinity to positive infinity. So with that in mind, let's work another example. Here we do have parentheses, so we're going to distribute first. Distribute the 6. 6 times negative 1. And on the second set, you're distributing a negative 1. There's an invisible 1 there. So negative 1 times 4. And negative 1 times negative x. Bring down the rest of the problem. We do have some like terms on the left. Let's combine. 6x plus x is 7x. And negative 6 minus 4 is negative 10. And at this point, normally we say, okay, we're ready to move the variable term. We want the variable on the left. So let's move this term that's on the right. And if we do just that on this step, it gets rid of x because 7x minus 7x is 0. I would have a negative 10 left on the left, and I get 0x on the right, and a negative 12. So I have a statement now with only numbers in it, no variables. We can decide if that statement is true or false at this point. Or maybe you prefer to go ahead and move the constant so that you have 0 on one side. You can certainly do that as well. I'll show it both ways. If you left it like this, then we would be comparing negative 10 to negative 12. Think about a number line. as you go further to the right, you're getting bigger. To the left, you're getting smaller. So let's say here's negative 10, negative 11, negative 12. Negative 12's to the left of negative 10, it's smaller. The point is towards the negative 12, so this is true. Now, if that's hard for you to think about, maybe you would prefer to add 12 to both sides. If you did that, your result would say 2 is greater than or equal to 0. Or you could have added the 10, that would work as well. But no matter how you do it, you still end up with a true statement. So to answer, let's put our answer in red. Because it's true, all real numbers, I'm going to abbreviate that, all real numbers are solutions. On the number line, I'm not even going to put any marks, I'm just going to shade the whole number line. And our interval notation would be negative infinity to positive infinity. So we would have all that in our answer. Now on the problems where it comes out false, you can just write no solution and that's it. The no solution does not require a graph or interval notation. So last concept in this video is compound inequalities. So you've got an expression with x in the middle. You've got two inequality symbols. So your goal is to isolate the variable in the middle. Now, if you just pretend like that left side is not even on there, and it just said 3x plus 7 is less than 28, you would subtract 7 first. Well, you're still going to subtract the 7 and subtract it here, but you are also going to subtract it on the left side. So you have to do it in 3 places. Whatever operation you do, you're going to do on the left, in the middle, and on the right. So now on the left, I have negative 3. I'm going to keep my symbol, 3x in the middle, and 21 on the right. To get the x all by itself, then, we divide by 3. And again, we're going to do that on the left and the right. So the result on the left is a negative 1. We divided by a positive 3, so the symbol stays. If I had divided by a negative number there, I would change both symbols. On the right side, we get 7. So now the x has been isolated in the middle. Remember to read compound inequalities. Start with the x. It says x is greater than or equal to negative 1 and x is less than 7. So to graph, we need 2 tick marks, negative 1 and 7. And x can be any number in between. The equal to bar is next to the negative 1, so we want to include the negative 1. The 7 does not have an equal to bar, so parentheses, we're not including the 7. Same notation on your interval. So that is all part of our answer as well. So again, that's called a compound inequality. Let's do one more example. So we want to get x by itself in the middle. The first step would be to add the 4. Well, let's see. I say that. We could do it, you know what? Let's do it a different way. You could add the 4 first and then clear the fraction out. But if I follow through with the order of the steps that I gave you, step 1 was remove parentheses, which we don't have. Step 2 was clear fractions, which we do have. So let's go ahead and do that first. So our only denominator is 2, then 2 is our LCD. We're going to multiply every term by 2. And let's see what that gives us. On the left, we'd get negative 12. In the middle here, on the fraction term, remember divide. So we divide 2 goes into 2 once, and 1 times 1 is 1x. And 1x is the same as just x. Minus 4 times 2 is 8, and negative 3 times 2 is negative 6. So that's what it looks like if we clear the fraction first. Now to isolate the x, we need to add 8. So in the middle, on the left, and on the right. So the left is negative 4, same symbol. Our x is by itself in the middle, and on the right we get a positive 2. So we have completed the solving, and certainly it is possible that you might get fractions on the left or the right side, and that's okay. Let's graph on the number line. Always make sure your smaller numbers on the left. X is greater than negative 4 and less than 2. So x is between. The negative 4 does not have the equal to, so we're going to use parentheses. The 2 does have the equal to bar, so, oops, must have messed that up there. Square bracket. On the 2. And same on the interval, parentheses, square bracket. So that is the end of our lesson on linear inequalities.